This is video part 6, and it is the last video in the series that covers the factoring packet. And we were talking in the last video about shortcuts for factoring, the difference of two squares as well as perfect square trinomials. Now we're going to look at a brand new type of factoring that you haven't seen before, and that's called factoring the sum or difference of two cubes. So we have nice formulas to do this factoring as well. Now most textbooks expect you to go through and memorize these formulas. Here at Yorktown we do have a special mnemonic that we use to memorize how to factor the sum or difference of cubes. And these are the mnemonics that we use. Crummy, crummy, SOPS. So let's look first at the formula and see if we can figure out how this fits. So we have a cubed minus b cubed, and it says that when you factor it, you get a minus b, and then you get a trinomial, a squared plus ab plus b squared. So let's take a look at how that happens. Well, a cubed to get to an a, what you're doing is you're taking the cube root of a cubed, which gives you the a value. And over here we have a b cubed. We're going to take the cube root of b cubed, and that'll give you the b value. So that's the crummy crummy. So the c for crummy crummy is cube root, cube root. So the first set of terms are made from cube root of both of these. Now one thing I should mention is the minus that was here, I can put that inside here. This is the cube root of negative b cubed. And that answer is negative b, because you can take the cube root of negative values. The other option is just to take the cube root of each of these and then just put the minus in between. It's up to you. Now, how do you come up with the second piece, which is the trinomial? Well, the mnemonic for that is SOPS. That means the first term is made from squaring the crummy crummy. That's where the square comes in. And this last component is also a square. So this b squared is made from squaring the second term from the crummy crummy. So this last part, this trinomial, is entirely based on this first set of factors that you calculated, the cube root, or the crummy crummy. Now the middle piece of this trinomial, the opposite product, that means take your a and your b value from your crummy crummy and you multiply them together and change the sign. So this was a times negative b, which is negative ab, but then you change the sign. It's the opposite of the product. So the negative of a negative ab is positive ab. Let's look at the second example. The cube root of a cubed is a. The cube root of b cubed is b. So that's the crummy crummy. And you can even label that above it if you want to. CRCR. That's what the crummy crummy comes from. So now, notice the middle here, the sign is positive because the originals were positive as well. So now we're going to create the second term. So this is the s and the s. I usually like to try to create those first. I usually do the middle term last. Take both of your crummy crummies and square them. So a is squared and b is squared. And then the center here is the opposite product. So we're going to multiply a times b, which we have here, and then change the sign, which is negative. Now to do some of these, you'll have to be able to do some of your perfect cubes pretty quickly. So we have 1 cubed would be 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, and 9 cubed is 729, and then of course 10 cubed is 1,000. So, and that's something that you might want to, frequently try to do quickly. It might be helpful to memorize those. Now you can also take perfect cubes of variables. So all you have to do is look at the multiples of 3 within the exponents. X cubed, x to the 6th, x to the 9th, x to the 12th, x to the 15th, and x to the 18th. These are all perfect cubes. All right, let's go ahead and take a look at the example on the top of the next page. So we have 125x cubed minus 216, And of course, you're going to want to use the crummy SOPS example. So what you'll see here is that if you take the cube root of each of these terms, so let's go ahead and take the cube root of 125x cubed. So cube root of 125 is 5, and the cube root of x cubed is x. And then the second portion of that is the cube root of negative 216, which is going to be a negative 6. So you'll see that's what they have here, this 5x cubed minus 6 cubed. So right here, you can see that we can label this as crummy. So that's that first part, 5x minus 6. Now we're going to take and do the SOPS portion. So creating the first and last term by squaring both of the crummies. So you can see they actually show 5x quantity squared. Notice it's in parentheses. So we're squaring the 5 and we're going to square the x. And then the 6 is squared as well. And then in the center here we have the opposite product, which is 5x times negative 6, but change the sign. So they've shown that as a positive. So when you simplify this, the crummy remains as 5x minus 6, but the 5x quantity squared becomes 25x squared. 5x times 6 is 30x, and then 6 squared is 36. All right, let's go ahead and do two of these examples together. So 29, crummy SOPS here, and if you want to, you can, like I said, you can always write down the crummy and then the symbols to help you remind yourself of what you're actually working for. So the cube root of 125x cubed is 5x. And the cube root of positive 8 is positive 2. And you can make a large enough parenthesis that you can do the first and last terms right away. 5x all squared is 25x squared. 2 squared is a positive 4. And then here in the middle, opposite product, multiply 2 and 5x together, which is 10x, and then change the sign, so you have minus 10x. All right, let's go ahead and take a look at number 36. So let me scroll down. So for number 36, we've got looks to be a cubic binomial, but the big question is, notice that 24, is that a perfect cube, or is 81 a perfect cube? Well, in fact, in this case, it's not. However, we can always take out a GCF first. So I'm going to go ahead and pull out the greatest common factor, which is a 3. And I'm left with 8x cubed minus 27y cubed. In this case, you'll see that I do have integers now that are perfect cubes. The 8 is a perfect cube of 2, and the 27 has a perfect cube. It's a cube root of 3. So I'm going to go ahead and rewrite the greatest common factor. And then I'm going to go ahead and do the crummy SOPS. So the cube root of 8x cubed is 2x. Cube root of negative 27y cubed is a negative 3y. And then I'm going to go and make my parenthesis large enough to do the squares. So 2x all squared is 4x squared. Negative 3y all squared is a positive 9y squared. And the middle term, I've got 2x times negative 3y, which is negative 6xy. Change your sign, and that's going to be positive 6xy. Down here at the bottom is a diagram that you can use to go ahead and follow the steps to figure out what you want to do with all of your factoring.